First, we will start by algebra. The multiplicative inverse of a matrix. The multiplicative inverse of a matrix. If A is A, B, C, and D, then A negative 1, which means the multiplicative inverse of the matrix A equals 1 over delta D negative B, C negative C, and A. What happened here? We move to the matrix A and we exchange the places of A and D and change the sign of B and C again. We exchange the places of A and D like this. A will be put instead of D and D will be put instead of A. Like this part. A is down and D up. And we change the sign of B and C like this, negative B and negative C. Then if the matrix A, B, C, D, then A negative 1, which is the multiplicative inverse of the matrix A, equals 1 over delta. And we do this part, which is we exchange the places of A and D and change the sign of B and C like this. Then where delta, what is delta? This delta, what is this delta? Delta equals, we change the matrix into what? Into determinant. We change the matrix into determinant. We convert the matrix into determinant. Why we convert the matrix into determinant? To be able to find a value of it. So if we change or convert the matrix into determinant, we can find the value of it. So it will be A times D minus B times C, like this part. A times D minus B times C, such that the answer not equals 0. The answer not equals 0. For example, if A equals negative 1, 0, 8, negative 2, prove that for the matrix A, there is a multiplicative inverse, then find it. Again, if A equals negative 1, 0, 8, negative 2, prove that for the matrix A, there is a multiplicative inverse, then find it. The solution: A equals negative 1, 0, 8, negative 2. So first we convert the matrix into determinant. We convert the matrix into determinant to be able to find the value of it. Then negative 1 times negative 2, as we see, minus 8 times 0, as we see. The answer is 2, which is not equal 0. So this condition is verified here. The matrix, the determinant, not equal 0, but it equals 2. Then for the matrix A, there is a multiplicative inverse. If the value of the determinant not equal 0, so the matrix has a multiplicative inverse, as we proved now. So to find the multiplicative inverse, we find the value of delta, which is 2. So A negative 1 means the multiplicative inverse of A equals 1 over delta times the matrix. After exchange the place of A and D and change the sign of B and C. So the answer will be 1 over 2. 2 is the delta. The matrix will be negative 2, 0, negative 8, negative 1, which is equals to negative 1, 0, negative 4, negative half. Solving two simultaneous equations by using inverse matrix. Again, solving two simultaneous equations by using inverse matrix. If we have two linear equations as follows. If we have two linear equations as follows. The first one is a1x plus b1y equals k1 and a2x plus b2y equals k2. These are the two linear equations. Then we can write them in the following form. A1, B1, A2, B2 times XY equals K1, K2. What are these matrices? A1 is the coefficient of X in the first equation. B1 is the coefficient of Y in the first equation. A1 is the coefficient of X in the second equation, and B2 is the coefficient of Y in the second equation. X and Y are then required to be found. Equals K1 and K2 are the answers of the two equations. So K must be after the equal sign. Here also K2 must be equal after the equal sign. Then we will sample for the first matrix as A, and the second matrix as X, and the third matrix as C. Then AX equals C means A times X equals C. As we see here, A times X equals C. Then, to find the value of X, which is X and Y, which is the matrix X and Y, to find the value of X, the value will be equal A negative 1, which means the multiplicative inverse of A times C. The multiplicative inverse of A times C. Solve the system of the following simultaneous equations using the matrices. Again, solve the system of the following simultaneous equations using the matrices. You will have example. 3x plus 2y equals 5. 2x plus y equals 3. The solution. 3, 2, 2, 1. 3 is the coefficient of x. 2 is the coefficient of y. The same for 2 and 1. 2 is the coefficient of x in the second equation. 1 is the coefficient of y in the second equation. Then x, y equals 5, 3. 5 is the answer of the first equation and 3 is the answer of the second equation. We will find delta. Delta equals 3, 2, 2, 1. 3 times 1 equals 3 minus 2 times 2 equals 4. The answer will be equals negative 1, which is not equal 0. So the multiplicative inverse of A equals 1 over delta times, we will exchange the places and change the signs. So 1, negative 2, negative 2, 3. The answer will be 1 over negative 2, 1, negative 2, negative 2, 3, 1 over negative 1. And the change we make for these matrices, we write it here. Then we multiply times negative 1. So the answer of the multiplicative inverse of A equals negative 1 to negative 3. Then x over x and y equals the multiplicative inverse of a times c, the multiplicative inverse of a times c, which is 5 and 3. Then we multiply as we studied before. The answer will be the multiplication. We will remember it now. The first row times the first column give me the first term. The second row times the second column give me the second term, the second term in the second row. So the answer is 1 and 1. Then x equals 1 and y equals 1. The solution set is 1, 1. Then the geometry. Equation of straight line. First, vector form. The vector form. We will start by the vector form. We have different forms to write the equation of a straight line. The first one is vector form. So, r vector equals a vector plus k u vector. This equation or this form is the vector equation of a straight line L. So, r vector and a vector represented the two directed line segments. Again, r vector and a vector, r vector and a vector represented the two directed line segments as we see in this figure. R vector and a vector represented two directed line segments. U vector is the direction vector. U vector is the direction vector. The direction vector is the slope of the straight line. The direction vector is the slope of the straight line. U, as we see here, is the direction vector. The direction vector means the slope of the straight line. K, what is K? K is a number belongs to R different 0. K is a number belongs to R difference 0. The second form called the parametric equations. This parametric equation is very easy. We will put instead of R, we will put instead of it x and y. And instead of a, we will put x1, y1. K will keep as it is. Instead of u, we will put ab. So u vector is equal a and b. What's a and b? A and b are the slope. A and b are the slope. Then the parametric equations. X equals x1 plus ka. Again, x equals x1 plus ka. And y equals y1 plus kb. So these are the two parametric equations. So these are the two parametric equations as we see in this figure. So there is the r vector and a vector. R vector we put instead of it x and y. A vector we put instead of it x1 and y1 as we see. Okay, then u vector we put instead of it a and b. Then the parametric equations are as we see. Third, we find the Cartesian equation. The Cartesian equation is x minus x1 over a equals y minus y1 over b. B over a equals y minus y1 over x minus x1. Again, the Cartesian equation is x minus x1 over a equals y minus y1 over b. So B over A will be equal y minus y1 over x minus x1. If B over A equals m, if B over A equals m, which is the slope of the straight line, then m equals y minus y1 over x minus x1. So this is the Cartesian equation of the straight line. Then this is the Cartesian equation of the straight line. So the Cartesian equation of a straight line is m equals y minus y1 over x minus x1. M is the slope. Okay? Then we will study the equation of a straight line in terms of the two intercepted parts from the two axes. Again, the equation of a straight line in terms of the two intercepted parts from the two axes. So, if we have x-axis, y-axis, and a straight line, and the required is to find the equation of this straight line. The straight line intersects x-axis at point A0. The straight line intersects y-axis at point 0, B. So, the intercepted part of x-axis is A, and the intercepted part of y-axis is B. Then, x over A plus y over B equals 1. So the equation is x over A which is the intercepted part of x-axis, y over B, which is the intercepted part of y-axis, equals 1. So A is the intercepted part of x-axis and B is the intercepted part of y-axis. The next lesson is the measure of the angle between two straight lines. The measure of the angle between two straight lines. So, if we have two straight lines, L1 and L2, and the angle between them is theta. So, to find the measure of angle theta, the rule is tan theta equals absolute M1 minus M2 over 1 plus M1 times M2. Again, tan theta equals absolute M1 minus M2 over 1 plus M1 times M2, where M1 is the slope of L1, M2 is the slope of L2, under the condition that M1 and M2 not equals negative 1. M1 times M2 not equals negative 1. Theta, the measure of the acute angle between the two straight lines L1 and L2. Again, the measure of the acute angle between the two straight lines L1 and L2. Next, the length of the perpendicular from a point to a straight line. Again, the length of the perpendicular from a point to a straight line. So, if we have a straight line, as we see, if we have this straight line and given its equation, which is ax plus by plus c equals 0, and a point outside the straight line, x1 and y1, and the required is to find the perpendicular distance from the point to the line. Again, the given is the equation of the straight line and the order pair of a point outside it, which is x1 and y1. The required is to find the perpendicular distance from the point to the line, which is called L. So, L equals absolute ax1 plus by1 plus c over square root a power 2 plus b power 2. Again, ax1 plus by1 plus c over square root a power 2 plus b power 2, where L is the length of the perpendicular from a point to the straight line. Again, L is the length of the perpendicular from a point to the straight line. X1 and Y1, a point doesn't belong to the straight line given its equation. Again, a point doesn't belong to a straight line given its equation. It means the point outside the straight line, that point. A is the coefficient of X, B is the coefficient of Y, C is the absolute term. The last lesson is called the general equation of the straight line passing through the point of intersection of two lines. Again, this lesson is called the general equation of the straight line. So the required is to find the general equation of a straight line passing through the point of intersection of two lines. So also what is the required? If we have two straight lines, L1 and L2, this is the point of intersection of these two straight lines. The required is to find the general equation of a straight line passing through what? Passing through the point of intersection of two lines. So the required is to find the general equation of the straight line. The general equation of the straight line passing through this point, which is the point of intersection of L1 and L2. Again, the given is what? The given is L1 and L2. Okay? What's the required? The required is to find the equation of a straight line passing through the point of intersection of these two straight lines. So, AX1 plus BY1 plus C1 equals 0 is the equation of L1. AX2 plus BY2 plus C2 equals 0 is the equation of L2. Let's have an example. Find the equation of a straight line passing through the point A and the point of intersection of the two straight lines. X plus 2y minus 5 equals 0 and 2x minus 3y plus 4 equals 0. Again, find the equation of a straight line. Means this one. He talked about this one. The required is to find the equation of this line passing through the point A. He give me the order pair of a point on the line required, on the required line, which is called A. So there is a point on the required line, which is called A, given, and the point of intersection of the two lines. So this one is L1, and the second equation is L2. This is the equation of L1, and this is the equation of L2. Okay, so the solution is we will try to solve these two equations simultaneously as we studied before in the third preparatory. So we will multiply the first equation by -2. Okay, so the answer will be -2x. 2 times -2 will be -4. -5 times -2 will be 10. And the second equation will be written as it is. So the answer is -7y plus 14 equals 0. This one will be cancelled and the answer will be -7y plus 14 equals 0. So we will try to find the value of y. -7y equals -14 by dividing negative both sides by negative 7, the answer will be y equals 2. By substituting 2 in any of the two equations, we will find the value of x, which is 1. So, the given point is A. This is given in the example. And we find the point of intersection of these two straight lines, which is 1 and 2. Then we will try to find the equation of a straight line passing through these 2 points by using the Cartesian equation. Y minus y1 over x minus x1 equals y2 minus y1 over x2 minus x1. What's x1 and x2? We will say that negative 2 is x1, 4 is y1, 1 is x2, 2 is y2. So, y minus y1, which is 4, x minus x1, which is negative 2, minus negative 2, the answer is 2, equals y2 minus y1. y2 means 2, minus y1, which is 4, minus 4, over x2 minus x1, 1 minus negative 2, 1 minus negative 2. It will be 1 plus 2. So, the answer is y minus 4 over x plus 2 equals negative 2 over 3. Then, by crossing multiplication, the answer will be the required equation is 2x plus 3y minus 8 equals 0.